Hello everyone. Have you ever taken a moment to ponder what it implies when we learn that a comet could be an entire fleet of objects moving in formation? This is the intriguing suggestion put forth by Avi Loeb, the provocative Harvard astrophysicist, concerning the 3Y atlas. If true, this hypothesis might completely transform our comprehension of interstellar visitors. Picture a celestial object with a tail directed towards the sun, something that seems impossible. It behaves as though the sun has less mass than we perceive. This might indicate the presence of a swarm of trillions of smaller entities, defying every known principle of cometary physics. Dr. Loeb recently released an analysis that could fundamentally alter our grasp of the 3Y. If he's right, we're not witnessing a typical comet but rather a phenomenon resembling a coordinated effort of multiple objects. Brace yourselves, because this theory challenges what we think we know about what's out there. Throughout November 2025, the 3Y revealed something that left astronomers astounded, a teardrop shape in its coma aimed at the sun. To grasp why this is unsettling, one must remember that comet tails always extend away from the sun, as per the fundamentals of physics. Solar wind propels particles backward, creating the familiar tail we recognize. However, the 3Y atlas displays an anti-tail, a structure oriented towards the sun. It's akin to witnessing smoke moving down rather than upward, or water flowing uphill. Simultaneously, astronomers observed an even stranger phenomenon. The object exhibited non-gravitational acceleration, as if it were responding to a sun with slightly diminished mass. Loeb proposed a theory that might sound like science fiction but is rooted in rigorous mathematics. What if the 3Y atlas is not solitary? What if it's surrounded by a swarm of smaller objects that exhibit a different acceleration? These smaller objects would remain closer to the sun in relation to the main object because it is consistently being pushed away. Imagine this scenario: you're walking with a friend while a constant wind pushes you backward. Your friend, unaffected by the wind, would naturally advance ahead. This mirrors what would be occurring in space. And here's the intriguing part: the estimated size of this formation corresponds perfectly with the size of the observed anti-tail. Now, here's the aspect that might keep you up at night. If this theory holds, we're dealing with truly remarkable numbers. Loeb calculated that a swarm of trillions of particles, each carrying just a tiny fraction of the 3Y's total mass, could yield a surface area significantly larger than that of the main object. To visualize this, imagine a trillion miniature mirrors flying in formation around a central object. Individually small, they would collectively reflect far more light than the primary object. Here's the unsettling detail: this swarm would create the effect of a coma that reflects nearly all solar light, culminating in the brightness surrounding the 3Y atlas. What's even more astonishingly accurate? Observations from the Hubble Space Telescope reveal that this phenomenon is indeed occurring. Practically all the light stems from the coma, not the nucleus. Loeb's theory elucidates a puzzling issue for astronomers. Why does the teardrop shape towards the sun maintain consistent dimensions both while approaching and moving away from it? In typical comets, tails shift considerably as their distance from the sun changes. However, if the anti-tail consists of a swarm of objects that don't evaporate, it would retain a stable geometry, consistently pointed towards the sun. Think of it as a perfectly aligned military formation that remains organized, irrespective of movement speed or direction. If Loeb's assertions are correct, the implications are groundbreaking. Firstly, the 3Y atlas would represent a complex system of multiple objects maneuvering in a coordinated manner. Secondly, the members of the swarm wouldn't suffer mass loss from solar radiation, suggesting that they could differ in composition from standard ice. Thirdly, this formation would endure for durations that should be impossible for natural gravitational aggregates to sustain. Lastly, theoretical predictions correspond seamlessly with independent observations. But here arises the uncomfortable question that few dare to voice: what type of natural objects could maintain such precise formations for such an extended period? Loeb concludes his analysis with a question that ought to trouble us all: if the anti-tail is indeed associated with a swarm of objects, what are the characteristics of these entities? Are they rocky fragments or something beyond that? This seemingly simple question conceals deep implications. As we assess the prerequisites for sustaining such precise formations, we venture into a realm that natural physics struggles to clarify: entities that don't evaporate under solar radiation, flawless movement and coordination for months, gravitational stability unattainable by natural assemblies, and constant geometry irrespective of solar proximity. Let's candidly consider the possibilities. One option posits that perhaps there exist natural processes we're yet to understand that can create and uphold such precise configurations. It could also be that the diversity of objects in the universe is far more extensive than we realize. Alternatively, maybe we are witnessing evidence of deliberate coordination, objects maintaining formation not by mere chance but through intentional design. Loeb's theory, founded on physics and mathematics, ultimately compels us to question what natural force could possibly sustain trillions of objects in precise formation for months traversing our solar system. If there's no recognized natural force strong enough for this, it leads us to alternatives that mainstream science often avoids. What stands out most in Loeb's analysis is its mathematical accuracy. This isn't vague conjecture, it's precise predictions that harmonize perfectly with independent observational data. It's akin to piecing together a puzzle where every fragment fits flawlessly, yet the completed image reveals something that shouldn't occur in nature. Loeb's theory yields specific, testable predictions. If it is indeed a coordinated swarm, the anti-tail should maintain a consistent geometry as the object retreats from the Sun. The formation should retain stable proportions regardless of distance. Spectral analyses should reveal distinctions between the central object and the anti-tail components. In the coming months, as the 3Y Atlas continues its path, we'll have the chance to validate each of these predictions. Should they all be confirmed, we would encounter evidence of something unprecedented in the realm of astronomy. Avi's swarm theory could signify a pivotal moment in our understanding of interstellar visitors, not only for explaining observational anomalies but also for pushing us to contemplate possibilities we've preferred to sidestep. If trillions of entities can uphold coordinated formation across interstellar space, traversing our solar system while sustaining precise geometry for months, what kind of natural phenomenon could account for this? And if we fail to uncover a satisfactory natural explanation, we must confront the likelihood that we are witnessing signs of intentional organization on a cosmic scale. Loeb's question, are they rocky fragments or something beyond, might become the most crucial question in contemporary astronomy. If the answer reveals something greater, it would fundamentally shift our perception of our role in the universe. It would suggest that we are not alone and that other intelligences might possess technological abilities we can barely fathom. Now, what do you think? Are we confronting extreme natural phenomena we have yet to comprehend? Or is there tangible evidence of active coordination of objects on an interstellar scale? The swarm theory could hold the key to realizing that the 3Y Atlas is more than just a visitor. It could be a manifestation of capabilities that redefine our understanding of what is possible in the cosmos. Share your theories in the comments below. If you'd like to follow every unfolding aspect of this story that may be unveiling the first concrete evidence of interstellar technology, please like, share, and subscribe. The universe might be far more populated and organized than we ever imagined.